Alright, how you guys doing today? This is Mr. Muscarella coming at you. And in this video, we're going to take a look at finding the exact values of expressions involving inverse trig functions. This is going to be the first part of two videos on this subject. So let's go ahead and take a look at one thing that you've got to have down. And that's understanding what is the difference between these two expressions. Hopefully, by this point in your math career, you kind of start to understand this. The first one is going to be the ratio of sides of a right triangle. So I want to know what is the sine of pi over 3 or the sine of 60 degrees. That's going to give me a certain ratio or a certain number. Whereas on the second expression, the arc sine or inverse sine of 1/2, for that expression, I'm trying to determine what angle measure gives me the ratio of 1/2 when I'm looking at the sine function or the sine trig ratio. So when I look at the opposite and the hypotenuse, which angle would I end up with that would give me 1/2 as that ratio? So those are two differences you're going to have to be able to make sure that you recognize, and by this point I'm sure you do. So with that out of the way, let's go ahead and get into our first example. So here we've got to find the exact value of the expression. And what we're going to do is we're actually going to work with this inside piece first, this arc cosine of 1/2. So the very first thing that we're going to do is we're going to go ahead and determine what quadrant this is going to be located in based on our domain restriction for arc cosine. So what I'm going to kind of think about is our general ASTC, which stands for all students take count. This just represents which quadrants each of the trig functions are positive in. Now, cosine, arc cosine, is limited to this domain restriction right here from 0 all the way over to pi. So within 0 to pi, now I have to analyze the 1/2. And it's a silly question, but I gotta ask, is 1/2 positive or negative? Ooh, yes, it's positive. So that means my angle that I'm looking for is going to have to be here in quadrant 1. So once I've determined the quadrant that my inverse trig function is located in, what I'm going to do next is actually just kind of draw a triangle of that. So I know I'm in quadrant number 1, so I'm going to go ahead and just set up a reference triangle based on that. I'm just going to call this theta right here because I don't know what the angle is yet. 1/2, since I'm given cosine, cosine's relationship of the adjacent to the hypotenuse. So that's 2 and that's 1. This piece that I'm missing right here is the y-coordinate. So the third thing that I'm going to do is actually find the missing side using the Pythagorean theorem. So I have 2 squared, that's my hypotenuse, that's going to be equal to 1 squared plus y squared. Now when you go ahead and solve this, you'll end up with a value of square root of 3 for y. So you have to be careful because sometimes depending on what the quadrant is, you might have to use the negative value or the positive value. So you just have to pay attention to where your triangle is located, which quadrant the leg is that you're trying to find. So we end up with root 3 for the value of y. Now what I'm going to do next is look at this outside function. Once I have my triangle drawn, what I'm going to do next is just kind of look at what I've got to find. I want the sine. So the sine is going to be this piece right here, the square root of 3, because that's the value of y, and then over the hypotenuse, which is 2. So my final answer is just square root of 3 over 2, and that's it. You're done. No big deal. But wait a second. Is there another way to do this problem? Of course there is. And then this technique, this one is, for those of you guys that recognize some things about the unit circle real quickly, you might find this way a little bit better. When you take a look at this inside angle, you might already recognize like, hey, that domain restriction is definitely going to put me here in quadrant number 1. I know that my angle has got to be in quadrant number 1, so you might kind of think about it like this. I know that that angle is 60 degrees. So, or pi over 3, depending on whether you're using degrees or radians. So then if you know you're trying to find the sine of 60 degrees and you already have that memorized, you know that's square root of 3 over 2, you can actually think about that whole process that way. So either technique will work for this type of problem. There'll be some problems where the angle that you're given isn't on the unit circle, so that's where you would have to use the first technique. But if you do have one that you recognize as being on the unit circle, you could go ahead and use this. Either way, you'll have to come up with a value of root 3 over 2 when you're all done for this expression. So here we are, we've got the cotangent of the arc sine of negative 1/2. So okay, so I'm going to go ahead and draw my piece right here, ASTC, and then arc sine. So arc sine is the domain restriction on that is between pi over 2, and remember, you can't call this 3 pi over 2 because it's negative pi over 2. So my domain restriction for arc sine is either in quadrant 1 or quadrant 4. Now I've got negative 1/2, which means my sine is going to be negative. I'm looking for that. So then that tells me that when I actually draw my reference triangle, I'm going to draw that down here in quadrant number 4. So that ratio, arc sine of negative 1/2, so opposite is negative 1, and then the hypotenuse is 2. So now I'm trying to find the x coordinate, or the x value for that leg. When I go ahead and use Pythagorean theorem to do that, so you come up with a value of square root of 3 for x. Now to find the cotangent of that triangle, when I look at all the values of my sides, remember, cotangent is going to be x over y, which in this case is square root of 3 over negative 1, and when we simplify that, negative square root of 3. Now I've got one more for you guys to try, and this one I want you to go ahead and do this one on your own. Check this one out. So we've got the cosine of arctangent of negative 3. And this one's going to be a little bit tricky because sometimes people are going to have a little bit of an issue here with this negative 3, but I think you can handle that. So go ahead and hit pause, try this one on your own, and then come back and see how you did. Alright, rock stars, how'd you do with this one? Hopefully you came up with a value of square root of 10 for the radius. Then when you figured out the cosine of this triangle for this angle, you ended up with 1 over square root of 10, but remember you have to rationalize, so it's going to be square root of 10 over 10 when you're all done with that. The tricky part on this one might come in the beginning, because tangent, if they give you a whole number, remember that's going to be the same thing as negative 3 just over 1. So that might have been a spot where it tripped up some people, but hopefully you're not one of those people. And if you are, no big deal. Now you know how to do this type of problem. So that's it for this video. Thanks for watching. And by now, you guys know how to find exact values of expressions for inverse trig functions. You guys have a great day, and I'll catch up with you again later on. Peace out, Cub Scout.